Okay, hello everyone. This is Dr. Jafari. I'm going to explain to you the project for Motor Drive lab class, which I defined for my student David Naines. And the project defined as controlling AC motors using Arduino microcontroller. This is the control block diagram, which we want to control the speed of the fan by measuring the distance of the balloon above the fan. So basically, this is a closed loop system which we are feeding back the sonar sensor value, which is the distance of the balloon from the fan, and we compare it with the distance, the set point, which we usually put a potentiometer to receive an error, and then the error goes to the controller, basically goes to the DAC, digital to analog, and then it creates an error, and the error goes to the phase controller. This is a simple diagram. So we have the fan here, and that's a sonar sensor on top of it, and then we measure the distance. We would like to control the balloon distance above the fan by controlling the speed of the fan. The way the phase controller works, it receives 0 to 5 volts, and it converts to 0 to 120 volt AC signal, 60 hertz. And the way it works, if it's 100%, if it's at 100%, you have full cycle of the signal. And if it's like half, then we just basically half of the signal will pass. And since we have half, then we have half the speed. And if it's 0, we have 0. So that's the way how the phase controller works. And for the DAC, Dave came to the how to convert to digital to analog, which came out with the idea of resistor ladders, which is our bunch of stack of resistors, which we have from the least significant bit to the most significant bit, and with the series of resistors, which the vertical one is the half of the horizontal one. And this is the actual setup, which I think I'm passing to Dave, and Dave is going to take over from this point, and he's going to demonstrate his setup.
Alrighty, thank you, Dr. Jafari. As Dr. Jafari mentioned, my name is David Naines from the EET390L lab. The goal of this project, as Dr. Jafari mentioned, is to control the distance of a balloon above a fan using an ultrasonic sensor. And the way this is set up right now is the ultrasonic sensor is situated in the center of the fan pointing outward. That is fed back through a sensor wire to the Arduino. The Arduino then compares the set signal or set point with the set with a potentiometer and determines an error to be sent out the digital analog controller in the form of the resistor ladder. The the analog signal sent out of the resistor ladder is then fed through to a phase control relay. That phase control relay takes the AC signal from the wall and basically chops the signal up and sends it back out to the fan to control the speed of the motor. The Arduino is outputting 3 values to the serial port right now on the monitor over here. The very left-hand value is the set point from the potentiometer. The center value is the current reading from the Arduino on the ultrasonic, and the 45 value is maxed out. And then the 180 is the current decimal value of the 8-bit register being sent out to the digital analog converter. I chose 180 as a value as during testing that was the value that just started to turn the fan up. So rather than wait to get from 0 to 180, we went ahead and started at 180. Alright, so let me go ahead and grab an object. The initial idea was a balloon, but we had to borrow a glove from the medical students. So as the object is placed over the ultrasonic sensor, the value of the ultrasonic sensor becomes lower than the set point, and the Arduino determines that the fan speed needs to be increased and starts incrementing the digital value out to the digital analog controller. And once we reach a sufficient enough speed, the balloon will start to float above the fan. And the Arduino is trying to keep the balloon the set distance away, plus or minus 2 counts for error that we put in there. We change the potentiometer and increase the set point. The fan will in turn also, or the Arduino will also in turn increase this fan speed to get the balloon up to that value. And in turn, if we go the other direction, the Arduino will slow the fan down to maintain that distance. The farthest away we were able to get was maybe 30 counts. Let's see. At this point, the balloon is so far away that the ultrasonic sensor is not picking it up. So the fan slows it back down until it can see it and then begins to speed it back up. That's about it. Thank you.
Thank you.